All right, we have one last video for section 1.3. We're going to do an example relating to average value, and then we are going to go ahead and state the mean value theorem for integrals. So example 7 is telling us that a local politician has been in office for 2 years now. T years after being elected, the percentage of the electorate who approve of the politician is given by A of t equals 52 minus 10 e to the minus t. What is the politician's average approval rating during their time in office so far, and when does the function A of t attain its average value? So we have two questions here that we want to answer. The first one, just what is the politician's average approval rating? Well, we have a function describing approval rating, and we just learned how to take average values. So we want to think about integrating the approval function A of t. We're asked to find the average approval rating during their time in office so far. So their time in office has spanned from 0 years after being elected to 2 years after being elected, since they have been in office for 2 years now. The last thing that we need to do is remember that average value is not the integral. It is 1 over the length of the interval times the integral. So the length of this interval here is 2, so I have a factor of 1/2 out front. All right, well, let's continue this computation. So I have 1/2 times the integral from 0 to 2 of my approval function is 52 minus 10 e to the minus t dt. And again, we'll talk a little bit more about how to do these antiderivatives in the future, but in order to compute this, we want to use the fundamental theorem of calculus and find an antiderivative of our integrand. Again, I'll kind of let you check on your own that we have 52t is certainly somebody whose derivative is 52, and plus 10 e to the minus t is a function whose derivative is minus 10 e to the minus t. So we have this as our antiderivative, and we want to evaluate it from 0 to 2. Meaning that we have our 1/2 floating around out front here. We first evaluate at 2, so we're looking at 52 times 2 plus 10 e to the minus 2. And now we want to subtract away the same function evaluated at 0. So 52 times 0 plus 10 e to the minus 0. Well, this is a big string of numbers that you can plug into your calculator, and if you do so, you find that this is approximately equal to 47.7%. Cool, so we have an average approval rating of 47.7% across this politician's time in office. So we've answered the first question, but we still have the question, when does the function A of t attain its average value? This means when is the approval rating exactly equal to 47.7%? So here what we want to do is we want to say, well, 47.7 equals A of t, which is that 52 minus 10 e to the minus t. And let's see, I can add 10 e to the minus t from both sides, and I can subtract 47.7 from both sides to tell me that 10 e to the minus t is 52 minus 47.7. I want to also divide by 10, so e to the minus t is 52 minus 47.7 divided by 10. To go ahead and continue isolating t, we need to take a natural log on both sides. So the left-hand side becomes minus t, the right-hand side becomes natural log of 52 minus 47.7 all over 10. And we need to multiply both sides by -1 to complete the process. So t is equal to minus natural log 52 minus 47.7 all over 10. And again, if you plug these numbers into your calculator, you get that this is around 0.84 years. So about 0.84 years after being elected, this politician has an approval rating equal to 47.7%, which is the average of that politician's approval across their 2 years in office. So this is kind of nice. I mean, we find that not only can we compute the average value, But at some point, the politician actually attains that average value as their approval rating. And in fact, we'll find that in general, that's what's going to happen. We're going to both have an average value, and the function that we're averaging is going to attain its average value at some point, provided that it's continuous. So here we have the mean value theorem for integrals, which says that if we have a continuous function on the interval from a to b, there is at least one point. So that phrase "at least" there is important. So that there's at least one point C in AB, so that f of C equals the average value, 1 over b minus a, integral from a to b, f of x dx. So we're finding here that at some x value, the y value is equal to the average. So we also want to think about why this is true. And so maybe we want to suppose for the moment that it weren't true. Suppose that the graph of f of x never actually hit its average value. So what would that look like? Well, if the average value were larger, so here's f av, here's a, and here's b. If f av were larger than f of x the entire time, well, then that certainly wouldn't be the average value of this function. The average value can't be larger than than all of the y values of the function, so this case can't happen. Maybe what could happen is f av is smaller than all of the y values, but again, that wouldn't be the average value of this function because the average can't be smaller than the minimum. So what we conclude is that at some point, the function has to be smaller than its average value, and at another point, the function has to be larger than its average value. And by the intermediate value theorem from Calc 1, and the fact that f of x is a continuous function, we know that at some point, we can't avoid passing through this middle average value here. We're larger at one point, we're smaller at another point, we're continuous, so we have to pass through that middle value. So that's what's going on with this mean value theorem for integrals, and there will be a couple more problems like example 7, which really relate to this mean value theorem.